For many centuries, bridges have been an essential part of society. The main purpose of a bridge is to overcome a physical obstacle, such as water, a valley, or a road, by spanning over and above it. There are multiple types of bridge designs, some of which will be listed in the following video. Arch bridge, suspension bridge, cable stayed bridge, cantilever bridge, beam type bridge, and truss bridge. The purpose of this task was to build a bridge made up of only superglue and no more than 200 grams of spaghetti. The bridge should be built to be able to carry multiple times its own weight. The bridge design that the group decided on proceeding with was quite unique and much different to the bridges researched and the bridges that the other groups built, which was obvious on the day of the testing. The bridge that the group designed was very simple and straightforward, but also strong and effective. The bridge did not have as much of a height component as other bridges did, nor did it consist of as many members. The design of the bridge was based around having thick, strong members made up of many spaghetti strands. The purpose of this design was to have two main members that can carry the load. The closest type of bridge that this bridge relates to is the arch bridge. This is a bird's eye view plan of the bridge. And this is an elevation plan of the bridge. The process of making the main members was by making two bunches of approximately 50 spaghetti strands each, then overlapping each bunch with each other by approximately 5 centimeters. The two bunches were held in place while overlapped by one group member, while another group member placed superglue in the middle where the overlapping was to connect all the spaghetti strands. The glue was left to dry for a moment. After drying, superglue was placed on one end of the member, left to dry, then repeated on the other end. After both sides had dried completely, superglue was spread over the entire member for extra added strength and sturdiness. This entire process was repeated in order to have two main members. The first member weighed in at 48 grams, and the second member weighed in at 49, which is 97 grams in total. The overlapping in the middle was to provide more tensile strength to the bridge in the area that was going to take the most load, which is where the weight plate was going to be placed during testing. The bridge was also glued together to have an upwards curvature. This tactic was used to provide extra tensile strength to the members and consequently to the bridge as a whole. To be considered a bridge, however, these two main members must be connected. To connect these two main members, smaller members must be made to go across them. To complete this, 15 spaghetti strands were bunched and snapped into approximately 10 centimeter long pieces. The pieces were glued together at one end, then dried, then repeated at the other end. Similar to the longer members, superglue was spread over the smaller members as well for added strength and sturdiness. This was repeated 11 times in order to have 12 smaller members in total. Each smaller member was weighed and on average weighed 6 grams, which equals to 88 grams total. Displayed is a photo of all the members before being joined together. After all the members had completely dried, the next step was to join them. The plan was to glue the smaller members in a zigzag pattern across each side of the larger members to form a crossing over pattern with the smaller members on each side. This arrangement of the members and design, as well as the final bridge, can be observed in the photos displayed. This pattern was chosen to imitate a common truss, in which the main members support the load, but the smaller members provide extra support and stability to the structure. The total weight of the bridge ended up being 185 grams, and the total length was 44 centimeters. The total width was 8 centimeters, and the total height was 4 centimeters. A small improvement that could have been made would have been to evenly sand the ends of each member in order to reduce the amount of weight of each member, which in turn would reduce the total weight of the bridge. This would have allowed the use of more members, which consequently would have increased the structural integrity of the bridge. Another improvement that could have been made would have been to incorporate vertical components into the bridge to absorb the downward force of the load during testing. An additional improvement would have been to bunch the spaghetti strands more evenly and tightly, by bunching them in a tight cylinder, for example, before applying the superglue. This would have increased the strength of each member, in turn increasing the total strength of the bridge without adding any extra weight. The following video is footage from the testing of our bridge.
Yeah. It's 1, 2, 3 kilograms. 4.
It was clear that aesthetically, our group's bridge was one of the lowest ranked, if not the lowest. The group learned from the results that it may have been wise to incorporate more vertical members into the bridge to distribute the load more evenly, instead of placing all the pressure on 2 main members. Although the bridge was not the worst performing bridge on the testing day, as some had failed as soon as any pressure was applied, it definitely could have been built more technically. Aside from the changes that could have been applied to the bridge, this task helped the group build their teamwork skills, including communication, using it to work efficiently. This task also gave the group more knowledge on the different types of bridges. We hope you have enjoyed our video. Thank you.